Let's talk about what makes points collinear and coplanar. If points are collinear, then they all lie on the same line. The opposite of collinear is noncollinear. If points are noncollinear, then they do not all lie on the same line. For example, points A, B, and C are collinear because a line can be drawn straight between them. Whereas point D in this diagram is non-collinear with points A, B, and C because there's no way to draw a straight line that goes through all 4 points. Let's look at the word collinear and break it down into its parts. The prefix co, co, means together. And then the main part of the word is linear. You probably remember that from Algebra 1. Linear functions make straight lines. So all that this word means is that they are points together on a line. And then of course the prefix non means not. So collinear means all together on a line. Non-collinear means that they are not all together on a line. Let's try an example. I want you to draw 2 points. Now if you don't have paper and pencil handy, that's fine, just do it in your mind. But go ahead and draw 2 points. And then you're supposed to label them with names. I'm going to call one of those points W and the other point X. The next step is to draw a third point that is non-collinear with the points that we just drew. All that means is that you have to put it somewhere that would not be on the line that connects W to X. So I'm going to put my point right here, and as it says, I'll call it Y. Y is non-collinear with W and X because there's no way to draw one straight line through all 3 points. The last step in these instructions is to draw a fourth point, and that point should be collinear with W and X. I'm going to put that point over here and call it Z. Now that's not the only place that you could put it. You could also put it here instead, and it would still be considered collinear. Collinear doesn't necessarily mean that the point has to be between the other 2 points like it is right now. All that collinear means is that a straight line could be drawn between those points. So W, Z, and X are collinear because I could draw a straight line through all 3, but Y is non-collinear with the others because you couldn't fit Y on the same line with the other 3 points. Now let's talk about coplanar. Coplanar points are a lot like collinear points, except instead of the points all lying on the same line, as they do for collinear, they all lie on the same plane if they're coplanar. Which again, if you just break that word down into its parts, co means together, planar means plane, so it's together on a plane. And non-coplanar would be the opposite. It's points that are not all together on the same plane. So let's take this example. Points E, F, G, and H are coplanar because they're all on that green plane. But point K would be non-coplanar with the other 4 points. Remember that planes can be kind of hard to visualize on a screen or on a piece of paper because point K isn't really on the screen or on your piece of paper, whichever you're looking at. Point K is floating somewhere above the plane. So even though it looks like if you were to extend that parallelogram that represents the plane, it would eventually intersect with K, you have to imagine that K is not on the same plane as the other 4 points. It's also important to note that any 2 points are always collinear, and any 3 points are always coplanar. Let me explain what I mean. Imagine sitting in your classroom and looking at the 4 walls and the ceiling and the floor. There's 8 corners created, right? There's one in the top left-hand corner, one in the bottom right-hand corner, one behind you, etc. There's a total of 8 corners. Pick any 2 corners that you want to. You can draw a straight line connecting those 2 corners of the room. Maybe you picked the top left-hand corner and the bottom left-hand corner, so you're just connecting along the vertical line that connects the ceiling to the floor. That's a unique line. If you only have 1 point, so you're, for example, just talking about the top left-hand corner of the room, that's not specific enough to create a unique line. It could be the vertical line that goes up and down between the ceiling. It could be the horizontal line that goes across the front of the room, or the horizontal line that goes along the side of the room. One point is not enough to make a line. You have to have 2 points to make it a line. And any 2 points can always be connected with a line, which is why it says any 2 points are always collinear. For planes, you need even more information. If you just pick 2 corners of your classroom, it's not specific enough to create a single plane. So for example, let's say you take the top left-hand corner of the room and the top right-hand corner of the room. Well, which plane am I talking about? Am I talking about the ceiling? The ceiling would contain those 2 points. Or am I talking about the front wall of the classroom? That wall would also contain those 2 points. So 2 points is not enough to make a unique plane. You need 3 points. So let's say, for example, that you use the top left-hand corner and the top right-hand corner, as well as the top left-hand corner behind you. That would indicate that you're specifically talking about the ceiling. So 3 points are always coplanar. It takes 3 points to make a unique plane. And then one extra piece of information is that if 2 lines or rays or segments intersect, then they have to be coplanar. So for example, look at the tile floor in your classroom. Each of those intersecting lines between each of the tiles indicate that since those lines are intersecting, those lines have to be coplanar as well. So that's all you need to know about collinear and coplanar points.